So lastly, to move much back closer to home, there's this Chandra observation. Does anybody want to guess?
Pumpkin.
Pumpkin. That's not even close.
I was just trying to help.
Oh, look at that.
Who?
Jupiter.
Oh,
Yeah. Did anybody in here? I know somebody in here. Did anybody in here go to the 515 planetarium show? Okay. So, what's going on here? That's right. What we have here is the equivalent.
It's the Vikings and the, Valkyries. Is
That's
what's going
right.
on there.
Well, what's going on here is that Jupiter has a magnetic field. The sun has a solar wind of energetic charged particles that's going out into the solar system. Some of those are being funneled down to the poles of Jupiter, exciting the gas there and generating X-rays, just like we see here on the Earth. These are aurora pictures that my wife and I took 2 years in Iceland, anyway. So Chandra studies things from near to far. It studies very energetic objects from explosions. It studies very energetic objects from objects that are just very, very hot. And it's been going on for 20 years, and we are currently funded for another 10 years of operation from NASA. And
That's great.
So we're looking forward to a lot more of this. And
is there less than a pound of iridium in that telescope?
Less than a pound of iridium. It's a good question, and I should know because I did the studies about what we should coat it with, but a pound. I'm going to guess that there's definitely less than a pound, but I would have to do the calculation to be sure. But you can, the mirrors are, the outer mirrors are about 1.2 meters in diameter and also about 1.2 meters long. It's the inside of a cylinder, and it is 400 angstroms thick. So you can go and calculate that. I don't know the answer off the top of my head, but I would say it's less than a pound. I'd be surprised if it was more. Yeah.
Yeah.
So that's all I have for you.
Well, thank you so much, Pat. We have a couple of minutes for questions. Well, we don't, but I don't care because all the timing is, and this is a small group anyway, and so I think we can kind of throw the schedule out the window and do what we want. I'm happy to skip all of my talks except Alexei Leonov later. Are there questions for Pat? Yes.
Yeah, I'm puzzled by the these flares that occur, or any kind of matter, or energy of matter that seems to be ejected when you have these from the black holes. Because isn't the gravitational pull of a black hole so great that nothing can be ejected from a black hole?
Yeah, that's a good question, and one that is that's asked a lot actually, because we oversimplify these things. The material is falling into the black hole, but before it crosses that event horizon of the never to return, it gets so hot that you get these explosive events. So the explosive events are happening outside the event horizon. They're happening because of the ultra high gravity, but the material itself is still well outside of that never to return point. I will say, though, that you can see the effects of it. If you look at the spectra of those things, the spectra are shifted towards different wavelengths that has to do with being in a very, very high gravitational field. So when you study the spectra from those flares, you can get a very good measure of the gravitational field from those shifts.
While others are thinking their question, I'm going to take and ask you, what's this? That was just released. Can you tell us a little bit about it?
This is this is a recent image released from Chandra, and this is a mosaic. Really, the background is optical image of a cluster of galaxies. And what it's the gravity of that cluster of galaxies is acting on light coming from behind it in such a way that it is the gravitational field of the cluster bends the light and makes it form sort of a lens, and that's what's forming those arc-like structures. The purple is that hot gas in clusters that I was mentioning before. That's the X-rays tracing out where this very, very hot gas is. And so as I said before, you'd look at this before, if you turn the X-rays off, you'd see all of these galaxies, but why is that lensing looking the way it does? Where is the mass? Well, the X-rays are showing you where the mass is. It's not showing you all the mass because most of it is dark matter, but the X-rays are following the dark matter and they're showing you where that gravitational lens is sitting.
So I remember the Hubble image, of course, but it looks like that image got a spray tan. That's how that looks to me. Are there any other questions? Yes.
I have a question on as far as the dark matter versus dark energy. Other than calculating it to exist, how do we observe it if it's unobservable?
Well, that's a very, very difficult. Well, it's a difficult question, but it's also a difficult thing to do. The dark matter we can observe in the sense that we see its gravitational effects, right? We can look at a galaxy, we can see its structure and calculate from the points of light that we see in it how much mass has to be there. Then we can also add up all the light we can see, and we can say, I know that on the average stars are this bright, so stars of this mass are this bright. I can add that all up and get the mass. And it's not nearly enough to explain how the whole thing is bound. So that is mapping or measuring the dark matter. It's not seeing radiation from it because it doesn't seem to radiate in ways that we're able to observe. Dark energy, again, the only thing we can see from it is its effects. We know the universe is expanding. We know that there's a bunch of gravity, so that expansion should, in principle, be slowing down. It's not.
So it's something that we can deduce but not observe yet.
You can observe the effects, but not the
directly
stuff.
observe the stuff.
Yeah,
Not
you watch
directly
the
observe-
stuff
that's
having
right.
an effect on
That's-
the normal matter around it.
Yeah, so if I'm going to the store and I want a jar of dark matter, that's going to be kind of hard to get.
That is going to be hard to get.
Make a lot of money bottling that. We could just have a jar. It's a jar of dark.
That's and it's heavy.
Yeah, right. Question in the back corner.
Quick question. So, since our universe is expanding and accelerating, does it accelerate at the same or similar rate? And if not, do you know why?
Do you mean, does it accelerate at the same rate everywhere?
Yeah, everywhere, all the galaxies.
Yes,
Go
I
ahead.
think what you're getting at is it's universal from what we observe. It's not like this part of it here. Once you take out the local attractions of gravity, the universe as a whole is going through a uniform experience of this dark energy, is I think the best way to say it.
Right.
And moreover, it does appear to, although it's changing the expansion rate, they refer to it as a well described by a constant, which is that lambda cosmological constant.
Question.
Yes, last
I
question.
read that there's a mirror universe that we haven't discovered yet. Could a portion of the dark matter be antimatter?
No, not as we know it, because we would know the signatures from antimatter. If there is another such universe, it may have the imbalance of matter. We have an imbalance of matter to antimatter. It might have the flip-flop, but
And it has evil Pat Slane.
no, this one has evil.
Oh, that's a good place to end.